Hey guys, so the measures of an equilateral triangle will always be 60. So we need to think about that. It is a triangle. All sides are equal. Of course then, all angles are going to be equal. So we take the total amount of angles, measure of angles in a triangle, 180, and we divide it by 3. And that's where we get 60, the actual degree amount. The best name for a triangle with the measures of 45, 90, and 45 is a right triangle because it's 90. And 45 means that it would be isosceles. It would have two congruent angles with the 45, making it isosceles. And then a triangle will have one measure that is greater than 90 degrees. Just going to try to fix this a little bit here. Well, greater than 90 degrees, greater than 90, means that it would be obtuse. A triangle will have one measure greater than 90 degrees, and the other angles will be less than 90 degrees. Let me just zoom out a little, and maybe that will help. Too far. We're having a hard time finding this happy medium right now. Technology difficulties. All right, now we're going to talk about triangle ABC is congruent to triangle PQR. Well, angle R is going to be congruent to angle C because they're in the same position. They're in that matchy-matchy order. And then we move down here, and we're going to talk about triangle ABC. Okay, triangle ABC. Let's try and get focused. That's better. Is across from side BC. So here is side BC of that triangle, the side, and the angle across from it, the angle across from it is angle A. Number 6, all interior angles of a triangle, interior 1, 2, 3, will sum to 180. And now we're going to refer to the diagram. All right, we're looking at, it says, the legs of the right triangle. So here is our right triangle right here. And the legs, they make up that 90-degree angle where we see that little box. So it's AD and DB, or BD. They're in DA. All right, and it says, name the vertex angle for the triangle ABC. Well, this is an isosceles triangle because it has two legs marked congruent. So at the top of those two congruent legs is the vertex angle. Where that A is, we would call it angle BAC or angle CAB. The base angles of the isosceles triangle, which we're using 3 letters again, are right at the bottom of the two congruent legs. So it might help you if you turn your paper this way to see that these would be the bottom 2 angles. And again, you need to name them with 3 letters. So you would say angle, because we're angles we're talking about, ABC and angle ACB. And then down here, this is where things started to get a little challenging for people. Okay, I'm going to just show you all of my work because that way you can hopefully write it down a little better. I recommend drawing a diagram. Triangle BLT. So it gives you the different angle measures. B is x plus 42, L is 3x minus 18, and T is negative 2x plus 34. So you're going to take all of those angle measures and add them together and set it equal to 180. You're going to combine like terms and you'll get 2x plus 158 equals 180. All right, now I'm going to move this 158 over. So since it's a positive, I'm going to subtract it from both sides. And I'll end up with 2x equals 22. I divide by 2, and I divide by 2, and I get x equals 11. X is 11 for number 10. All right, and here is number 11. Well, if we can actually see it. This one was a really tricky problem for a lot of you, which is totally understandable because it's a tricky problem, period. Let's see if I can't just move this over a little bit. All right, so it says that the measure of angle L is 2x plus 49, And the measure of angle M is 5x minus 53. All right, and then it wants you to find the measure of angle P. Well, both of these sides were marked congruent, which should have been your indicator that this would be an isosceles triangle, meaning that the two base angles are congruent. So since this is 2x plus 49, since angle L is 2x plus 49, angle P would also be 2x plus 49. So we'll take those two angles, or one of them, multiply it by 2, and then add it to the third angle and set it equal to 180. You'll end up having 4x plus 98, these two bottom angles combined, plus 5x minus 53 equals 180. Combine like terms. 9x plus 45 equals 180. Subtract 45, 9x equals 135. And then you get x equals 15. Well, that's great, but you're not done. You still need to find angle P. All right, so since angle P is 2x plus 49 as well, you're going to take that 15 and plug it in. 2 times 15 plus 49. 2 times 15 is 30. 30 plus 49 is 79. Your answer will be 79 degrees. And then we move down here to this triangle. And it tells us that the measure of angle A is 33. The measure of angle E is 68, which we're just going to say this is E over here. And the measure of angle AEG is 45x minus 23. Well, angle A was a little bit of extra information. We didn't really need to know it. So what I'm going to do to find x is I'm going to do 68 plus 45x minus 23 equals 180. These form a straight line. That's why I'm setting them equal to 180. I'll combine like terms and get 45x plus 45 equals 180. I'll minus 45 and minus 45, get 45x equals 135. And divide by 45, x equals 3. I still need to find AEG, so I'm going to plug it in. 45 times 3 minus 23, and I'll get 135 minus 23 equals 112. So your answer would be 112. And there is a much, much simpler way of doing that. If you figured it out, congratulations. Okay, so here's a tricky one. I mean, I guess maybe they're all a little tricky. The biggest hint here is that this is an equilateral triangle and that the perimeter is 33. You may have seen one of this when we played grudge ball. So this would be 3x minus 13 plus 3x minus 13 plus 3x minus 13 because it's an equilateral triangle and all the sides are congruent. I'm going to take that 3x minus 13 and multiply it by 3. And then I'll set it equal to 33 because that's the perimeter. All of the sides added up. I'll end up with 9x minus 39 equals 33. I'm going to add 39 to both sides, add it because it's being subtracted. I'll end up with 9x equals 72 and x equals 8. When I divide by 9 and divide by 9, x equals 8. All right, we move down here. And this one, whew, this problem was a beast. Let's just show you all of the work for it. And hopefully that will make a difference. Okay, so we have triangles DEF and LKM. And I'm going to write them side by side so that I can see their corresponding parts. All right, D is equal to 9x minus 61. K is equal to 39. L is equal to 5x plus 3. And F, right here, is equal to 14y minus 12. I'm going to go ahead and solve for x first. And since these two angles, D and L, correspond to each other, I'm going to take 9x minus 61 and set it equal to 5x plus 3. So I have those set equal. Now I want to get my x's on one side and my 64 on one side. So I'm going to add 61 and add 61. That's where I get the 64. And I'm going to subtract 5x and subtract 5x and get 4x equals 64. Now I need to divide by 4, and I'll end up with x equals 16. X equals 16. Y gets a little bit trickier. So what I'm doing with y is I'm going to take this x and I'm going to plug it into this triangle. All right, and I'm going to, or actually I'm going to plug it into this triangle. Sorry, I wasn't looking at my work. I'm going to do 5 times my x, which is 16, plus 3, plus 39, this angle, and then plus this angle, which I'm going to use 14y minus 12. So all of these angles added up and set it equal to 180. I'll combine like terms, and I'll get 110 plus 14y equals 180. Multiplying these, adding this, and subtracting this. And now I want to move this over. I'm going to subtract 110 and subtract 110 and get 14y equals 70. Now divide by 14 and divide by 14 and get y equals 5. Whew, that was a problem. Okay, let's now look here. Our triangle congruency statements. All right, it's kind of hard to see the whole paper, but this would be triangle KTS is congruent to triangle ETS, the corresponding parts ETS, and then Y. Well, it tells us that T is the midpoint of KE, so both these two segments are congruent. And it also tells you that KS is congruent to ES. So this would be, remember, cover up one triangle if you have a hard time seeing it, side, side, side. All right, now this tells us that T is the midpoint of AU, so that means AT and TU is congruent, and that C is congruent to G. One thing that we need to be able to recognize is these are vertical angles and congruent. So we would say triangle CAT is congruent to triangle G, right, because it has the matching arcs, and U, the one without any arcs, and T, the one with one arc, GUT. And cover it up, and hopefully you will see that it is angle, angle, side. Angle, angle, side. All right, I'm going to pull this up a little in hopes that we can get a good picture. Okay, and then here we have triangle EAT and triangle RAE are right triangles. Well, that's all it tells us. We know that they're right triangles and that they share those sides. But we can't prove them congruent, so EAT isn't congruent to any triangle, and you can't prove. Hypotenuse leg wouldn't work here because you only have a leg congruent, not hypotenuse, hypotenuse. And then down here, when we get to 18, it says that LD bisects RE. So these guys are congruent. All right, we're just going to mark these guys congruent. And then it says that DR and EL are parallel. All right, so we're going to envision those as our parallel lines, right? These are our parallel lines right here and right here. And this is going to be a transversal that cuts through here, right here. So these would be alternate interior angles. And we would say that these are congruent as well, right? So we could say angle, side, angle. Angle, side, angle is what you want to write for this one. Okie doke. Let's look back here at 19, and we're almost done, guys. All it tells us is that C is congruent to R, and that A is congruent to U, and that these two are congruent because of vertical angles. Well, that's triple A, and if you remember, triple A does not prove triangles congruent. So you would say you cannot prove and they're not congruent to anything. AAA isn't coming to save you, and don't touch the butt. And then our last one here, we finally made it to the end of our study guide. Let's mark it up first before you do anything, all right? D is the midpoint, right? Right here, D is the midpoint of TG, this segment, and KR. So I would mark here, and here, and here, and here. Okay, we want to prove that KT is congruent to RG. So D is the midpoint of TG, that's given. All right, now they're saying, hey, TD is congruent to GD. Oh, well that's just definition of a midpoint. And then it says D is the midpoint of KR. But don't forget that that was given up here also, so there's another given for you. And lastly, KD is congruent to DR. Again, definition of a midpoint. Then it says angle, KDT is congruent to angle RDG. Well, those would be vertical angles. And then why are they congruent? Well, that would be, if you cover it up, maybe you'll see it better, side, angle, side. Side, angle, side. And now that we've proved them congruent, why is KT congruent to RJ? CPCTC. Corresponding parts of congruent triangles are congruent. You're done, and hopefully ready for the test. Bye, guys.